How many galaxies circle the Milky Way? Planets orbit the Sun in the solar system, and stars orbit the galactic center, which is usually a supermassive black hole in the galaxy. However, did you realize that galaxies also circle other galaxies? Yes. These are satellite galaxies, which are minor galaxies that orbit larger ones like the Milky Way. As you may have heard, Via Lactea is so massive that other galaxies orbit it in the same way as planets orbit the Sun. Would you like to learn more about these satellite galaxies and the effects they have on our galaxy? Let us investigate. Hello everyone, welcome back to Zeey. Subscribe to our channel and follow us. Our galaxy is a beautiful place. It is not only the galaxy in which we dwell, but it is also a towering object that stands out from other nearby galaxies. Although the Way Lactea galaxy is not the largest in the universe, it is a large galaxy within the local group. The local group is a cluster of at least 54 galaxies within a 10 million light-year distance zone, including the Milky Way, the Andromeda galaxy, and numerous smaller galaxies. The local group's satellite galaxies have fewer stars in general. They are significantly fainter than the Milky Way and other big galaxies, making detection and research more difficult. The Milky Way's satellite galaxies are fascinating because they are the closest celestial objects to us after stars and planets. Astronomers have discovered at least 50 satellite galaxies in the Milky Way's neighborhood. On the other hand, some are so faint that even the most advanced equipment has only lately found them. The following are some of the most important satellite galaxies circling the Milky Way. Large Magellanic Cloud. The Large Magellanic Cloud is an irregular dwarf galaxy that circles the Milky Way at around 163,000 light-years. It is one of the Milky Way's satellite galaxies and may be seen with the naked eye from the southern hemisphere. It was named after the Portuguese navigator Ferdinand Magellan, who saw it during his circumnavigation of the globe in 1519. The Large Magellanic Cloud is also one of the most well-known objects among amateur astronomers. It is extraordinarily brilliant despite having only around 10 billion stars, making it a smaller galaxy than the Milky Way, which has roughly 100 billion stars. Despite its modest size, the Large Magellanic Cloud is recognized for its high rate of star production. The star formation rate in this galaxy is predicted to be between 0.1 and 1 solar mass per year, implying that new stars are being generated at an extremely rapid rate, nearly 1 new solar system per year. Aside from star formation, the Large Magellanic Cloud is noted for its numerous globular clusters. Globular clusters are ancient spherical star clusters that are thought to have formed at the same time as the galaxy that hosts them. The Large Magellanic Cloud has had roughly 60 globular clusters found throughout history, making it one of the galaxies with the most known globular clusters. It was also a historically significant object of study since it was used to estimate the Hubble constant, which is a measure of the rate of expansion of the universe. Cepheid variable stars have been used to derive the Hubble constant by measuring the distance between Earth and the Large Magellanic Cloud. This has resulted in significant cosmological discoveries and improved astronomers' understanding of the world in which we live. Small Magellanic Cloud. It is another satellite galaxy of the Milky Way, located roughly 200,000 light-years away. It, like the Large Magellanic Cloud, is visible from the southern hemisphere and is named after Ferdinand Magellan. It is a dwarf galaxy with around 7 billion stars, making it smaller than the Large Magellanic Cloud. However, it, like its giant sister, is recognized for its high star formation activity with an estimated star formation rate of 0.02 to 0.03 solar masses per year. The Small Magellanic Cloud is also home to globular clusters, albeit in smaller numbers. There have been approximately 15 globular clusters detected, however it is believed that there may be more that have yet to be discovered. The Small Magellanic Cloud has been researched for its significance in the formation of low-mass stars and its relationship to supernovae, in addition to its importance in estimating the Hubble constant. Supernovae are the result of massive stars exploding, and the small Magellanic Cloud has seen several observed supernovae throughout history, which is quite impressive given that these star explosions can have a significant impact on the intergalactic medium and may influence the formation of new stars in the galaxy. Canis Major Dwarf Galaxy. This is a Milky Way satellite galaxy approximately 25,000 light-years distant. It is a spherical dwarf galaxy with an estimated mass of 500,000 solar masses with a star population that is ancient and metal-poor. The term metal-poor refers to a star or galaxy's low abundance of elements heavier than helium. Metallicity is an important quantity in astronomy since it relates to age and the evolution of stars. Metal-poor stars and galaxies are often older than metal-rich stars and galaxies because they formed earlier in the universe, when the creation of elements heavier than helium was far lower than it is today. It has also been discovered that the majority of the stars in our galaxy are quite old rather than young. The absence of brilliant new stars shows that star production ceased a long time ago. That is why studying this sort of galaxy is critical to understanding the evolution of the cosmos. The Sagittarius Dwarf Galaxy. It is approximately 81,000 light-years away. It is a spherical dwarf galaxy identified in 1994 that is one of the Milky Way's closest neighbors. Despite its tiny size, the Sagittarius Dwarf Galaxy has received a great deal of attention due to its likely significance in the origin and evolution of the Milky Way. According to research, our galaxy is breaking apart the Sagittarius Dwarf Galaxy, ripping off its stars and merging them into our own. This has led to the theory that the dwarf galaxy is the source of the stream of stars found in the Milky Way's cosmic halo. Don't you think that's impressive? The FORAX Dwarf Galaxy. It is roughly 460,000 light-years away in the constellation FORAX. It is a 1938 discovery of a spherical dwarf galaxy. Because of its vast population of globular clusters and dense groups of stars that orbit the galaxy, the FORAX dwarf galaxy has been the focus of extensive research. It has also been used as a reference for studying the structure and dynamics of dwarf galaxies in general. Despite its scientific significance, the FORAX dwarf galaxy has an unusual past. It was discovered in the 1930s by Australian astronomer Harlow Shapley while working in South Africa. Shapley named the galaxy FORAX after the constellation that represents a smelting furnace. He was interested by the possibility that the galaxy created from material ejected by a supernova explosion in a red giant star, similar to how metals are melted in a furnace. Sculptors Dwarf Galaxy. It is located roughly 280,000 light-years away from us. Harlow Shapley found it in 1937 as a dwarf spheroidal galaxy. The Sculptor Dwarf Galaxy, like other neighboring dwarf galaxies, is one of the most studied by astronomers due to its proximity and abundance of globular clusters. It is one of the dwarf galaxies with the greatest number of globular clusters known. Despite its modest size, the Sculptor Dwarf Galaxy is remarkable for its dark matter density, making it one of the greatest prospects for investigating the distribution and features of this matter. Consider that dark matter is still one of the universe's greatest mysteries. This galaxy is notable for being the brightest dwarf galaxy in the night sky at radio wavelengths, making it an important object for researching cosmic background radiation at these wavelengths. The Leo 1 Dwarf Galaxy. The Leo 1 Dwarf Galaxy is a Milky Way satellite galaxy situated in the constellation Leo, roughly 820,000 light-years away from us. It is one of the brightest and most massive dwarf galaxies ever discovered. Despite its modest size, scientists are interested in the Leo 1 Dwarf Galaxy because of its high heavy element-like metal abundance in comparison to other dwarf galaxies. As a result, it is a metal-rich galaxy rather than the metal-poor galaxies indicated above. Another fascinating feature is that the Leo 1 dwarf galaxy is rapidly approaching the Milky Way, making it one of the few known objects in the universe to move through space at such a rapid pace. The Leo Dwarf Galaxy 2. The Leo 2 Dwarf Galaxy is another satellite galaxy of the Milky Way, located roughly 700,000 light-years away in the constellation Leo. Despite its diminutive size, it is an intriguing galaxy to astronomers due to its distinct elliptical form which distinguishes it from many other dwarf galaxies. Leo 2 has a low amount of heavy elements like metals, making it a metal-poor galaxy like the others in the local group. Although Leo II has fewer globular clusters than other dwarf galaxies, it has a large population of variable stars which astronomers use to calculate the galaxy's distance. Furthermore, the Leo 2 dwarf galaxy has been home to one of the brightest supernovae seen from Earth, supernova SN 1991 Bg, identified in October 1991. This explosion was important to astronomers because it helped them better their understanding of supernova physics and their role in the formation of heavier elements. The study of satellite galaxies is an intriguing topic of study that takes us to the farthest reaches of our cosmos. We learn more about the nature of dark matter, galaxy formation, stellar evolution, and many other fundamental topics of astronomy by studying these compact galaxies around the Milky Way. Furthermore, satellite galaxies observe the most extreme occurrences in the universe, including as supernova explosions and supermassive black holes, helping us to better grasp how the universe operates on a grand scale. Despite their small size, these galaxies contain a plethora of information and mysteries that scientists are attempting to solve. We are reminded of the significance of looking beyond the obvious and exploring for what lies in the shadows by studying these galaxies. Many things in life can go unnoticed if we don't pay attention, much as satellite galaxies are concealed from view behind the Milky Way. Alright, that is all for this video. If you enjoy these types of videos, subscribe and let's discover the universe's biggest and most bizarre secrets together. Thanks for watching and see you soon.